Hi dear students, welcome to the next topic from electrostatics, which we are going to deal with something related to numericals. Okay, this topic you cannot see as such in NCERT textbook and in any other reference textbook as such, whatever I am going to take, because here I am going to convey certain problems actually. Okay, not really a topic, certain problems and a small topics which are coming for Neet and JEE examinations, but it not in a very frequent way. But there are two topics will be there. Today we are going to see it. Okay, so let's start without wasting the time. So write down the heading called RC circuit. RC circuit. RC circuit. What is called an RC circuit? R means resistance, C means capacitance. So far we have learned about resistance, so far we have learned about capacitance. Now we are going to do certain problems with respect to resistance and capacitance. Okay, there are two type of scenarios will be here. So let me explain with a concept. Okay, so the first in an RC circuit there are two types, or I can say like two models of questions may come. One is with respect to transient state, one is with respect to steady state. You will see these words in your questions like a transient state. If you see that word sorry, if you see that word, the approach is different. If you see something called steady state, then your approach is different. So let's start with the first one. There are two models of questions will be there. First model, first category is based on transient state. Transient state. Let me take an example so that this statement is clear. Transient means what? I mean the English word meaning sudden changes. All of sudden changes is called a transient. Just a transition, the noun forms, right? So let me take an example. I have a battery here. This is connected with a switch. The switch can be closed and open it back. And this is connected with a resistor and this is connected with a capacitor. That's what we call it as an RC circuit. Resistor, capacitor, switch and a battery voltage. Here, listen to the word carefully. When the switch is closed, that wording is important. When the switch is closed, which means that some changes are happening. When the switch is open, there is no current, there is no charges are not flowing through the system. Correct. When the switch is opened means the current from the battery cannot flow to the system. Or in another way, current will always flow in a closed path, a path which can travel from positive to negative. If it can start from positive and able to reach a negative, then current can form. But here, if the switch is opened, like this, switch is not connected, so current cannot, the charge cannot flow into this one. Okay, so now when the switch is closed means I'm just closing the switch like this one. So now the capacitor have no charges initially before the switch is closing. Resistor also no current. When immediately switch is closing means the circuit is going to face what called voltage. So this voltage source or the battery starts to give charges to the capacitor. And there are some changes are happening, sudden changes. That sudden change is called transient state. Sudden change is called transient. When the switch is closed, what will happen? There is a sudden change. This sudden change is also called transient state. It is a state of that circuit, and that sudden change is called transient state. During the transient states, what will happen? Battery will be here, positive polarity of the battery, so charges will be getting supplied by the positive plates. So this plate become immediately converted to positive, and the negative terminal is converted into negative, which means that what? Capacitor is like an hungry man. Okay, whenever his stomach is empty, If he is connected with a battery, what will happen? He will start to eat the charge very fast. He's like a hungry man, right? If you are very hungry and if you get a biryani, he will start to eat very quickly. The same way, he is very hungry initially because switch is open, no charge is not flowing. Now switch is closed. He see like a biryani is there, which means a voltage source will be there. So what will happen? He will start to eat the charges. So during these states, okay, the circuit can be redrawn. So during the transient state, the circuit can be redrawn, means the capacitor starts to eat the charges and the charges can flow. So the redraw circuit, positive, the redraw circuit is capacitor is become short circuited. This is important. This is my resistor, this is my battery. So during the transient state, when the switch is closed, sudden changes, so transient state, capacitor is short circuited. Short circuited means directly connected. You can just connect it with a wire. Its effect is like that. Capacitor short circuited. Capacitor short circuited. This is a very important point. So transient state or sudden changes are happening, the capacitor will behave as a short circuit. Now we need to find out what is the current flowing through the circuit when it is a transient state. Current is equal to what? Current is equal to voltage by resistance. Total voltage given to the circuit is V and the total resistance of the circuit is R, and you got I is equal to V by R. So this is the current flowing through the circuit. Okay, so whenever you see the word, there are three words I mentioned. When the switch is closed, you imagine this is a, not an imagine, this is called a transient state. When suddenly the switch is closed, then it is a transient state, or in another way the question will be specified transient state. So any three words they can use. Transient state, sudden changes, or when the switch is closed. So that time it is something called transient state, and during the transient state capacitor will act as short circuit. You can just forget about the capacitor, and the capacitor is sealed like a with a wire. This sealing, just a connections with a wire, that is called short circuit, means I shorted. Okay, so short circuit, and this condition is called a transient state. Very important. Okay, the sudden changes in short. Next one. Okay, there are some intermediate steps also will be there, but yeah, as of now this is enough for you. And the next one is called steady state. Steady state. Steady state, the representation the same way. We have a resistor and we have a capacitor. The difference is like here we have a switch will be there, right? And the switch, the statement is like this: switch is closed for longer time. Switch is closed for longer time. Switch is closed for a longer time means voltage, resistance, capacitor. Switch is immediately closed, we say it is a transient state. Now I close a switch. After 5 minutes and I'm coming and observing what is happening in the system. This is system or this is circuit. After 5 minutes I came and have a look and I see what is happening here. Quite simple. What will happen means when you close the switch immediately, capacitor will start to eat the charges because he is an hungry man. And once his stomach will be completely full, is he able to eat further food? No, he is not able to eat further food. He will stop. He will say, hey, enough. Hey, enough. My stomach is full. I don't want any charges. So he will not accept the charges. He will not accept the charges means charge cannot flow. So during the circuit, during this time, how the circuit can be redrawn as? Redrawn as means capacitor is cut. Capacitor is cut. Capacitor is cut means no charges are not further following. So during the steady state, I can say capacitor is open circuit. Capacitor is open circuit. Capacitor is not short circuit. When you see the word called switch is closed for a longer time, which means the time t is equal to infinity, means after a very longer time when the switch is closed will be this is a switch which is closed for a longer time, infinite time. If you see such word in the question, then that is also called a steady state, and during the steady state capacitor will act as an open circuit. So in this circuit, can you tell me what is the current will be here? Current cannot flow because the wire is broken. You imagine you have a tube light. Okay, so you have a switch connections, and from the switch connections you have a tube lights will be there, and when you switch on, the current is passing to the tube light and the tube light is glowing. Tube light will have positive negative, so positive to negative, and the current is flowing and coming back to the switch and going to the tube and coming back to the switch and going to the tube. So it's a closed path. Switch will have positive and negative. Tube will also have positive and negative. So when you switch on, current will be coming. Switch on means you are giving a connection between positive and the negative. So current is going like this. Whenever, so current is going from positive to the positive of that tube, and from there it is negative, and from the tube negative it's going to switch negative, and this is, it's like a closed path. Whenever some wire is broken in between, you cut the wire, what will happen? The tube lights will glow? No, tube lights will not glow because it is called open circuit. Open circuit and short circuit is a very common term we are using in the entire physics. Open circuit means wire is broken. Short circuit means wire is connected as such. So wire is broken. So what will be the current will be here? Current will be equal to 0 because it is open circuit. So remember this concept, this is very important. Transient state and steady state. When the switch is immediately closed, capacitor will act as a short circuit. When the switch is closed for a quite longer time, then it is called steady state. During the steady state, capacitor will act as open circuit. Remember this one. Based on this, we are going to solve a question. Okay. Fine. So we will see one example question. One example question. We have a battery and we have a resistor like this, and we have a resistor and we have a capacitor like this. Okay, this resistance is 10 ohm, this resistance is 10 ohm, this is equal to 2 microfarad, and this is equal to 5 volt. Okay, so I'll just connect a switch like this one. So two models of questions framing. When the switch is just closed, when the switch is just closed, when the switch is just closed, what is the value of current? What is the value of current? First question. Second question, in the steady state, what is the value of current? Again, two questions will be there. When the switch is just closed, what is the value of current? When in the steady state, what is the value of current? So we will answer this question as a two-part, A and B. When the switch is just closed, so in the first case, when the switch is just closed means transient state or steady state? Transient state. Transient state capacitor state is what? Short circuit or open circuit? Short circuit. So we will redraw the circuit for this one. Capacitor is short circuit. So shorted. Short circuit means we are just connected like this. So this is 10 ohm and this is 10 and this is 5. We need to find out the current I. So we need to find the total resistance. So R equivalent, resistance are connected in parallel. Total resistance means what? Capacitance are connected in parallel means C1 plus C2. Resistance are connected in parallel is equal to capacitance are connected in series. So R equivalent is equal to, parallel means R1 R2 divided by R1 plus R2. If this is a capacitor, then how I can written as C1 plus C2, volta. Capacitance parallel, resistance series. Resistance series, capacitor parallel. That's all. The formulas will be getting interchanged. So here we have the resistance formula. So we'll see 10 into 10 divided by 20, 100 by 20, which is equal to 5. So current is equal to voltage by resistance. Voltage is 5. 5 by 5, which is equal to 1 ampere. So when it is at switch is just closed, this switch is just closed, I close the switch, what I can say, capacitor is short circuited, so current will be equal to 1 ampere. Next, the second part. In the steady state, what is the value of current? In the steady state, what is the state of capacitor? Steady means after a long time, capacitor is fully charged. Capacitor will not accept charges, so it becomes open circuit. So we'll draw the diagram. This is 5 volt. This is resistors 10 ohm and we have a resistor 10 ohm, and this is open circuit. Wire is broken, no connection. This is 10 ohm. Any current is flowing here? No, this wire is broken, no current will flow through this 10 ohm resistor. So what you can see will be here, you can ignore this part of the circuit because there is no current is not flowing. So only you have this, so current will flow like this. Here this current will be splitted like this, current will be splitted like this. Okay, we know 1 ampere current will be here, so 0.5 will go here and 0.5 will go here, 1 ampere is coming from here. But here current will not go there because it is wire is broken, open circuit. In that cases, current is equal to voltage by resistance. Voltage value is how much? 5 volt. So 5 divided by 10, which is equal to 1 by 2, which is equal to 0.5 ampere. This is the case. Okay, hope you understood what we have done so far. We have learned about two important concepts. One is called transient state, another one is called steady state. Okay, these are the two things, and the main highlight of today's topic is in transient state, capacitor act as short circuit. This put it in a box on your notebook. In steady state, capacitor will act as a short circuit. In transient state, capacitor will act as a short circuit. In steady state, which means switch is closed for a longer time, the capacitor will act as an open circuit. Capacitor, steady state, capacitor, open circuit, no current is flowing through the branch. That branch is a dead branch. Okay, so current will be flowing only this way, and this currents will be equal to, I have not marked the current. Okay, this current I is equal to V by R, which means 5 by 10, which is equal to 1 by 2, and that is equal to 0.5 ampere. So always remember this concepts in a very very clear way. Okay, based on that the questions may come, we need to attend the questions. Okay, this is a very regularly asking kind model of questions for Neet and JE based on RC circuit. Why this question is very much important in the chapter is means you are learning more about resistance in current electricity. You are learning more about the capacitance in electrical potential and capacitance chapter. Now, if the testing agency is placing a questions like resistor with a capacitor, which means you have to have a knowledge of both current electricity knowledge and the knowledge from electrical and potential electrical potential and capacitance chapter, which means they are actually interconnecting the two chapters. So always the questions are in a physics which will have a connections between the chapters. Okay, so this is a simple kind of questions to depict what is the concept called transient state and what is called the steady state. Hope you understand the concepts very clearly. Only 2 points you have to remember. In transient state, capacitor will act as short circuit. In steady state, capacitor will act as an open circuit. This is the key point of this one. Okay, so 2 things we have learned. We'll move to the next topic. Okay. Okay, so in current electricity or even in capacitor also, we have learned the concepts called a very brief concept called Wheatstone's bridge. Okay, while I'm doing the equivalent capacitance, I told what is called a Wheatstone's bridge. To capacitance ratio C1 by C2 is equal to C3 by C4, then it is called a Wheatstone's bridge. Now the next topic is non-Wheatstone's bridge based circuit. So you can write an heading non-Wheatstone's bridge, non-Wheatstone's bridge based circuit. Whatever I am going to tell you is here, you can apply it for current electricity chapter also. Okay, so let's see, non-Wheatstone's bridge based circuit. What is called a Wheatstone's bridge? While I am taking my previous sessions, I told if you have some structures like this, for example, this is an example of a Wheatstone's bridge. Okay, now this is C1, if this is C2, and if this is C3, and if this is C4, and this is C5, then what is this? If it is okay, in Wheatstone's bridge, okay, in Wheatstone's bridge, C1 by C2 is equal to this ratio. C1 by C2 is equal to C3 divided by C4. Let me take an example. C1 equal to 2 and C2 will be equal to 6 and C3 will be equal to 1 and C4 will be equal to 3. Then if you take the ratios, we can see from this example we'll got 2 by 6. So 2 divided by 6, which is equal to C3 by C4, which means 1 divided by 3. Both ratios are equal. If you come across a ratio like this, both ratio, left hand side ratio is equal to the right hand side ratio, then what I told, you can ignore this capacitance. You can ignore this capacitance. So you can forget about the capacitance. In that case, how our equivalent circuit will come? C1 value already we know 2. So let me put it as 2 and the other value you know it is 6. So the middle value, whenever a balanced Wheatstone's bridges are coming, what is the meaning is like the voltage here, voltage at the point P is equal to voltage at the point Q. Whenever two voltages are same, current will be never flow from top to bottom or bottom to top. Whenever unequal voltages are coming, for example here 10 volt, here 0 volt, then current will be flow from higher voltage to lower voltage, that is from P to Q. Okay, so whenever a balanced conditions are coming, C1 by C2 and C3 by C4 conditions are occurring, then the meaning is like the P voltage and Q voltages are same, which means I can say Vp is equal to Vq. I already mentioned this topic to you, right? The same thing. So during the condition, the current is not flowing through the C5. Current is not flowing means it's a dead element. So I can forget about that. So I don't want to draw because no current, it's a dead element. What is C3? C3 is equal to 1 and C4 will be equal to 3. Okay, now we have to find the equivalent capacitance value. Now you know how to find out the equivalent capacitance value, right? These two are series connection. Again, the bottom two are also series connection, and this combination in parallel with this one. So what is the equivalent of this one? What is the equivalent of this one? 2 into 1 divided by 2 plus C1 C2 divided by C1 plus C2. So 2 into 1 divided by 2 plus 1. So 2 by 3. What's the equivalent will be there? 6 into 3. 18 divided by 6 plus 3. 9. So its equivalent is 2. Now these 2 and 2 by 3. The next circuit, if I am drawing the next circuit, we have two capacitance which are in parallel. Top one is 2 by 3. Bottom one is 2. Now these two capacitance are in parallel connections. We have to find the equivalent. 2 plus 2 by 3. C1 plus C2. So it becomes 6. So answer is 8 by 3. So 8 by 3 is the equivalent capacitance of this structure, provided if it has these values will be there. Then this is called Wheatstone's bridge. So in Wheatstone's bridge, while doing the question, that is very easy. Why? Because we have an options to eliminate the middle capacitor. Always remember C1 by C2 is equal to C3 by C4. You may get confused, not now, later after few months. C1 by C2 is equal to C4 by C3. No. Like this, vertically down. the wire is like this one. So wire is like this one, like this connection, C1 by C2, C3 by C4, like this. So this is what you want to take it. So here what makes us simplicity will be here. In our case the simplicity is because the C5 or the middle resistors we can ignore here. Middle resistance is, if the middle resistance C5 will be equal to 10, if C5 will be equal to 10 means you don't want to draw. Why? Because it is a balanced Wheatstone's bridge. C1 by C2 ratio is equal to C3 by C4 ratio. In that cases you can ignore, you can remove the middle capacitance. That's what our calculations are easier. Top you will get 2 series, bottom you will get 1 series connections, and these series become parallel, and parallel you can solve it and easily you can find it out. Okay, this is basically a balanced Wheatstone's bridge. So our topic is different, non-Wheatstone's bridge based circuit, which means if you come across a non-Wheatstone's bridge, what you will do, how you can do in a non-Wheatstone's bridge circuit, how you will going to solve such kind of question. This is what we are going to see now. Okay, so we are going to solve a non-Wheatstone's bridge circuit. We are going to find the equivalent capacitance of a non-Wheatstone's bridge circuit. So let's listen here carefully. I have a 1 microfarad capacitor. I have a 2 microfarad capacitor. I have something called another 2 microfarad capacitor. I want a 2 microfarad capacitor here. I want a 1 microfarad capacitor here. So I want to find out the equivalent. Question is quite simple. Equivalent capacitance between A and B. Equivalent capacitance between A and B. This is what is our expectations. This is what we are going to do. Okay, so now you see C1 is how much will be here? 1. C2 is how much? 2 microfarad. I am not writing now. C3 is equal to 2 and C4 will be equal to 1. The ratio C1 by C2 is not equal to C3 by C4. 1 by 2 is not equal to 2 by 1. Then that is an example of a non-Wheatstone's bridge circuit. In this cases, how you will solve, how you will find the what I can say, the non-Wheatstone's bridge circuit. There are 2 methods will be there. There are 2 methods will be there. First one is a very traditional method. Very traditional method. Very traditional method. The first one is a traditional method, and the traditional method first I will teach you, because sometimes we may able to use that method also very complex kind of questions. Afterwards I will teach you a shortcut method also. So first we will see the normal, the traditional method to solve these questions. Okay, to solve this question, listen very carefully to the board. This is, we need to connect it with a voltage source. You can assume like it's connected with a voltage source. So here it is plus, here it is minus. You assume Q amount of charge is flowing. This is the traditional method. So Q will be splitted here. I don't know what is the value of this one. Q1 and Q2 you can mark. Okay, now you have to mark the polarity of the plate. Plus will be here. So this is plus, this is minus. This is plus, this is minus. Okay, here other side will look negative. So this become, here Q is coming. So here definitely Q is going out. The total charges are coming in and which is going out. And this is a negative plates. This is a negative plate. So of course this is a positive plate. This is a positive plates. Okay, so we have to look into certain symmetry. See, let me make this to be clear. My hand touched over here, so it's got rubbed out. Okay, so fine. So 1 microfarad will have how much charge? Q1 charge. So here we have 1 microfarad. So 1 microfarad will have how much charge? Q1 charge will be here. So this will also have a charges of Q1. The C2 will be here. We already marked 2 microfarad. So this C2 will also have a Q2 coulomb. So here also Q2. Here also Q2, here also Q1, here also Q1. Next, what is the polarity of this one? The 2 microfarad. We need that polarity also. See, here it is Q1, here it is Q1, here it is Q2. Okay, and here actually I can say plus means I can mark it as plus q1 minus q2. Here I can say plus q2 and this is minus q2. Here I can say plus q1 and minus q1. Here I can say plus q2 and minus q2. Like this I am marking. Okay, like this I am marking. So q1 is coming will be here and plus and minus will be getting changed. Okay, so q1 will be here. Listen very carefully. This is plus q1, this is minus q1. Okay, and this is plus q2 and this is minus q2. Okay, this is also q1. Okay, quite simple. Q is the amount of charge which is coming will be here. Q1 and Q2 is splitted up. Q1 is splitted into plus Q1 and minus Q1 because plus is connected to the positive plates of the capacitor. So the other plate is negative. It's a parallel plate. Bottom side, I assumed the current is Q2. So the charge is Q2 and this is positive, so plus Q2 and minus Q2. So the charges are coming here. So definitely it should go out. So Q is coming, Q is going out. So 2 microfarad is holding a charges of Q2. So the same Q2 I marked will be here, but it's plus Q2 here, minus Q2 here. Why? Because the negative plate is connected here. So this is minus, this is also minus, this is plus. Now here, we have learned about some rule which is called Kirchhoff current rule in a circuit, right? Current electricity. What is Kirchhoff current rule? States that total current in a junction is equal to 0. Total current in a junction is equal to 0, or I can say incoming current is equal to outgoing current. Both are same statement. Incoming current is equal to outgoing current, or total current is equal to 0. There are two situations are there. When these two situations are there, which means if I consider this junction here is equal to 0. So here if you see minus q1 left side plus q2 will be there. So what should come will be here at this point. Here it is opposite because the total should be is equal to 0. So here I can write on as, listen very carefully, q1 positive and q2 negative. Now if you add all these two at this junction this is equal to 0 because you have left minus q1, right plus q2, and bottom you have q1 minus q2. If you add all this, the sum will be equal to 0. Minus q1 plus q1 0 plus q2 minus q2, it is 0. Okay, so q1 minus q2 will be there. What is on the other plates? The bottom plate will come. Bottom plate is just opposite. So q2 minus of q1 will come here. So this is what's the circuit. Okay, hope you understood that q1 is coming will be here and q2 will be here, and will look positive. So this side is positive, this side is negative. But the middle one, how should I mark the middle one? I know the total current will be equal to 0. Total current is equal to 0 means total charge is equal to 0. Total charge is equal to 0 means plus q minus q2 plus q2. So this all together, what is coming? Q2 minus q1. So what you need will be here q1 minus q2. Then only the total, the overall total is equal to 0. Okay, now we have a couple of equations will be there. I can written as q is equal to q1 plus q2. This is my equation number 1, first equation. Second equation, whatever I'm going to do means I'm going to apply the KVL in the first loop. Okay, so I'm going to apply KVL, Kirchhoff loop rule. KVL, Kirchhoff loop rule, Kirchhoff voltage law. Okay, Kirchhoff loop rule I am going to apply in Kirchhoff voltage law equations. So what I can see, I'm starting from here, I have to go like this. So we need, what is Kirchhoff voltage law? Total voltage is equal to 0 in a loop. We know the equations, Q is equal to CV. So voltage means what? Q by C. Okay, Q by C. Now we'll see, we'll apply for the first loop. Listen very carefully. We are going from positive to negative. Positive. So I'm starting from here. I'm starting and I'm going like this and coming back to the same position. So Q1 point I'm starting. So I'm going towards right. If I'm going towards right means I'm going from positive to negative means I'm going down. Going down, negative. Negative means going down from plus to minus. So I can say minus Q1 by C. C means and value 1 microfarad. Will coming here. Next one. Q1 minus Q2. I don't know Q1 is higher or Q2 is higher. I am assuming Just assuming, I don't know my assumption is correct or not. Finally, we'll get to know Q1 greater than Q2. If so, you can assume in any way, no problem. Q1 is greater than Q2 means this is a positive plate, this is a negative plate. So I'm going again from, so this is over. Now I am traveling like this. I'm traveling like this. So I'm going from positive to negative. Going from, for this plate, second plate, positive to negative means minus Q1 minus Q2 whole divided by its capacitance value 2 plus. Again will be here. Here I am going from minus to plus. So it is positive, minus to plus. So increasing. So Q2 divided by its capacitance value 2. Total voltage is equal to what? 0. Total voltage is equal to 0. This I have to solve it, and I have to solve it down and I have to find it out. Okay. So minus Q1 by 2 plus Q2 by 2 plus Q2 by 2. So this become minus 3 by 2 Q1 is equal to, this is equal to 0. Q2 by 2 plus Q2 by 2 means Q2. So take into left hand side minus Q2. Minus and minus become cancel. So I can say Q2 is equal to 3 by 2 times of Q1. This is important. Q2 is equal to 3 by 2 times of Q2 is equal to 3 by 2 times of Q1. So I got two equations. Q2 is equal to 3 by 2 times of Q1. Okay. So now what I am going to do means, you have that. Here I am clearing the board. Now what I am going to do means, listen carefully. Now I am substituting will be here. I know Q is equal to, okay, Q1 plus, what is the value of Q2? 3 by 2 times of Q1. So I am adding this one. So 2 plus 3, 5 Q1 by 2. So I can say Q1 equal to 2Q by 5. Q1 equal to 2Q by 5 we will substitute here. So this is our one equation, keep it in mind. And Q is equal to, okay, Q is equal to Q1 plus Q2. What is Q1? 2Q by 5 plus Q2. So which is Q2 is equal to 5 minus 2. So it is 3Q by 5. So we got two things. Now, so we now got the value of Q1 and Q2 by applying KVL, and the Q is equal to Q1 plus Q2. We know these two equations. So based on these two equations, we solve it and we find out what is the value of Q1 and Q2. But this is fine. Now I got Q1 and Q2. So I am clearing the board. I need some more spaces. What I am going to do means, I need to take another loop. Now this is a small loop I am considering. Now I am going to take another loop, but loop is like this. This is my loop. Outside I am going to consider. So I can say outside loop. Outside loop I am going to write, and equations will be here. This is plus Q and this is minus Q coming inside. Okay, I am going to write an outside loop equation. In an outside loop equation, so what will happen? In an outside loop, starting from here. Okay, so I'm going this capacitor and coming out. So this capacitor means what? Minus Q1 divided by total voltage. Okay, total voltage minus Q1 by, what is the capacitance will be here? 1 plus. What is here? Second, I'm going from plus to minus, again negative. So minus Q2 divided by 2 is equal to, I'm coming outside here, total voltage. Total voltage is equal to minus Q from here. Okay, I am starting from here and I'm going from 1 to 2 and 1 to 2, then I'm coming here, then I can see minus Q. Minus Q and plus Q will be the same, right? Because it is changed. So total voltage, here total voltage. So this is the voltage taken by the capacitor, this voltage taken by the capacitor is equal to the total voltage. So minus Q divided by, minus Q divided by, how I can say, total capacitance C equivalent. total capacitance is equal to C equivalent. So here outside loop means, okay, you don't want to get confused. I will make it little more clear. Okay, what is outside loop? Again, we'll apply KVL. So sigma V is equal to 0. KVL. This voltage we applied Q1 by 1. This is clear, right? And whatever will be here, plus to minus I am going. So Q2. So here I am going from minus to plus. Minus to plus. So you can think it's a battery. Now this is also plus minus battery, plus minus battery, minus plus battery, minus to plus. I'm going positive. So Q divided by the total charge is here Q. Because of the direction it is plus Q and minus Q. So Q divided by CE is equal to 0. Now this is clear to you. What is Q1? We can substitute 2Q by 5 minus this minus, keep it here, and plus Q2. Q2 is 3Q by 5. So minus 3Q by 5 and divided by 2. 5 into 2 plus Q by CE is equal to 0. All Q will get cancelled out. So I can say 1 by CE is taken here. Rest of things will be taken to right hand side. So it becomes 2 by 5 plus 3 by 10. So what I can do, 10 is taken as LCM. So 10 file 2 times. So it becomes 4. 10 will 10 1 time. So it becomes 3. It becomes 7 by 10. It becomes 7 by 10. The total capacitance is equal to CE. Total capacitance in terms of micro. So 1 by CE is 7 by 10. So what is CE? 10 by 7. CE is 10 by 7 microfarad. I have given already the values in microfarad. Okay, so the answer is 10 microfarad. If you solve this one, you will get 1.428, I guess. Yeah, 1.428 microfarad. 1.428 microfarad. Capacitance is equal to 10 by 7 for this question. If the same question is asking in current electricity, non-Wheatstone Bridge circuit for current electricity, then in that cases what you will get for here, R equivalent. R equivalent means volta of capacitor. Volta, just to reverse volta. Volta means how much will come? 7 by 10. 7 by 10 will come if it is a resistor based question. In this problem, like 1, 2, 1, 2. This case, the capacitance is 10 by 7, which is equal to 1.428 microfarad, and resistance value, if you are asking about the resistance value, then it becomes 7 by 10. Okay, hope you understood the non-Wheatstone Bridge based circuit. Okay, this is what is the concept will be here to solve in a very traditional way of non-Wheatstone Bridge circuit. This topic is not over. As I told before, we have to see the shortcut method also. We will see it on the next sessions. Hope you understood today's sessions and you have enjoyed it. Little bit of complexity will be there. I am not saying it's very simple. Just to draw it on your notebook, practice it couple of times so that it will be easy. So enjoy your study and have a nice day. Thank you.